So when you're trying to write the empirical formula of a compound, usually what you start with is the percentage of each element in that compound. And that's what you did here. So you had chromium. And instead of writing it as 68.4%, we're going to write it 68.4 grams. And that's just the strategy. That's what you do. And the reason why is because eventually you can cancel grams out. So if we have 68.4% chromium, then that would give us 31.6 grams of oxygen because we had 31.6%. So if you add those two together, then that would be 100%. So that means that those are all the elements present in that compound. We look at the molar mass of each element, and chromium is 51.996. So we'll divide that by 51.996 grams. Then you do the same thing with oxygen. The mass of oxygen is 15.999. So you divide 68 by 52, 68.4 divided by 51.996. You get 1.315. Divide 31.6 divided by 15.999. Get 1.975. Then you look at these two numbers and you find the smallest number. And you divide both of those by the smallest number. And then you end up with about 1. Well, you end up with 1 and then with about 1.5. So that means that in this compound, you have 1 chromium for every 1.5 oxygens. That gives you CrO 1.5. But you never write a formula like this with a decimal. So we need to do something to make this a whole number. So we multiply the whole thing by 2. And when we do that, you get Cr2O3. So this is your correct formula when you have 68.4% chromium, 31.6% oxygen.
Wait, why did you multiply by 2?
Because you can't have a decimal as a subscript in a formula.
So would you always multiply by 2?
You just choose any number to multiply it by to get that to be a whole number. If it was 1.25, then you'd multiply by 4. Yeah.